7.1, the inverse of sine, cosine, and tangent. We need to remember back from chapter 2 when we were working with inverse functions. So over here on the right, my pen's not working, there it goes. Over here on the right, I have the sine function, y equals the sine of x. To find the inverse, I switch x and y. So I have x equals sine of y. Now I need to get y by itself. In order to get y by itself, I need to undo sine, which means I need the inverse of sine in order to undo sine. So I inverse both sides. This is just a review of what we were doing last chapter. I inverse both sides with the sine of y, or inverse of sine. Cancels, y equals sine inverse of x. So that's what I have here, where we do need to make sure we remember to switch x and y. That also changes our domain and our range. The original sine graph, your domain is all reals and your range is -1 to 1. It does switch for the inverse graph. You can see here your domain is now -1 to 1. And your range does go on forever. When we're dealing with inverse sine, we are going to limit what we are looking at. And we are only going to be looking from -pi/2 to pi/2 when we are solving any expressions or equations that involve inverse sine. So -pi/2 to pi/2, we will be looking at the right side of the unit circle. You might want to make a note of that on your unit circle, but we will also do that in class. Similar with cosine, you switch x and y, so that's what I'm doing here on the right side. I've switched x and y. To get y by itself, you take the inverse. So now we have y equals cosine inverse of x. So we are able to switch them. And just like sine, the domain and range change. And again, we're going to limit the range. We are only going to look at a certain section. As we go around our unit circle, it keeps repeating over and over and over. So we're going to just look at a small piece. So for cosine inverse, we will be looking from 0 to pi. And then very similar with tangent, x and y switch, solve for y. You can see the graph is switching around. I know I'm not spending a lot of time on this. We're going to spend a lot of time on the examples where you will practice using the domain and range for sine, cosine, and tangent inverse. All right, here we go. Example 1. This video, we're just going to do examples 1 through 3. So we're going to find the exact value, which means we're not going to use our calculator. We are going to use our unit circle, or if you have a trig chart, get your trig chart out. So I'm looking at my trig chart for this. Your unit circle is fine. You should have all of the 6 trig functions on your unit circle by now. If you haven't, you need to take the time to do that. In 7.2, we will be taking a look at secant, cosecant, and tangent more often. So we want those there. So to find the exact value, well, here I have tangent inverse. If I set this equal to theta, I want to undo the inverse. So that means I tangent both sides. And when that happens, your tangent cancels. So if I tangent both sides, take the tangent, this cancels, and I have tangent inverse equals -1. So now I'm going to use my unit circle. Where is tangent inverse? Where's tangent -1? Because it's inverse, this little thing here tells me we have the tangent or inverse of tangent. I am only going to be looking from -pi/2 to pi/2. So this is the right side of my unit circle. I only want to look, actually I'm going to use the quadrants. I'm only going to be looking in quadrants 1 and quadrant 4. If you're looking anywhere else and you put that answer, you're going to end up being wrong. It's correct for tangent, but it's not correct for tangent inverse. And we need to remember, what did we actually start with? We started with tangent inverse. So I'm looking in quadrants 1 and 4, and I want to find where is tangent -1. So I'm looking in quadrants 1 and 4. Tangent is -1 at 7 pi over 4. On the unit circle, here's 7 pi over 4. That is equivalent to -pi over 4. And that is actually your answer. Your answer needs to be between -pi over 2 and pi over 2. So 7 pi over 4 is the same position as -pi over 4. I'm going to move on to B, set it equal to theta. Sine of theta equals -√2 over 2. Sine is quadrants 1 and 4, sine inverse. So whereas sine -√2 over 2, that will be in quadrant 4. And again, I'm at 7 pi over 4, which is -pi over 4. So just a side note, 7 pi over 4 is the same as -pi over 4. 11 pi over 6 is the same as -pi over 6. 5 pi over 3 is the same as -pi over 3. And 3 pi over 2 is the same as -pi over 2. Definitely make sure you put that on your unit circle. So I'm going to move on to C, set this equal to theta. Cosine theta equals -√2 over 2. So cosine, we get a look in quadrants 1 and 2. So now I'm looking from 0 to pi, and I'm looking for -√2 over 2. And the cosine is -√2 over 2 at 135 degrees, which is 3 pi over 4. All of your answers will be in radians. If you can do this without looking at your unit circle, by all means do that. If you have these values memorized, you are going to be so much better off, so you don't have to keep referencing back. Here, I'm going to switch this. Sine of theta will equal 1. Don't forget, it's sine, so we're looking at quadrants 1 and 4. Where is sine 1? So quadrants 1 and 4. Sine is 1 at 90 degrees. 90 degrees is pi over 2. That is your value for theta. On to E, cosine theta equals 0. So now we're looking for where's cosine 0, and it must be in quadrants 1 and 2. Cosine is 0 at pi over 2. And then the last one, tangent theta is -√3. Tangent, we're looking at the right side. If you don't remember your tangents, you should remember your sine and cosine. Sorry. If you don't remember your tangents, definitely look at your unit circle. Tangent is negative in quadrant 4. So I'm going to make sure I'm looking in quadrant 4, and I get -√3 at 5 pi over 3. If I look back over here, 5 pi over 3 is the same as -pi over 3. I'll be somewhat forgiving on the quizzes, you guys, when you make that mistake of putting 5 pi over 3, but on your test, I will not be forgiving. Please make sure that you guys remember it must be between -pi over 2 and pi over 2. All right, example 2. I did not bring my calculator home. I could just completely space that, you guys, but you have this already worked out in your notes. I'm just going to help you with how to get started. If you look at your calculator, you do have a sine inverse, cosine inverse, and a tangent inverse button. Please make sure that your calculator is in radian mode. If we wanted this in degree mode, it would say find an answer in degrees. When it doesn't, we're going to find an answer in radians. So really simple, you guys. You're just going to take the sine inverse of 1 divided by 3. You must use parentheses. Same with cosine, same with tangent. So please make sure you guys practice that, and always remember to check your mode. All right, composite functions. Now the fun is going to begin. You're going to have to keep referencing this. It is a must. You are going to be given various composite functions, which means we're going to put two functions together. 2 sines, 2 cosines, 2 tangents. In 7.2, we will see a sine and a cosine, or a tangent and a secant. You want to make sure that you are paying attention to what you are given. You need to pay attention to that because it will tell you what x values you will be looking for. These values come from your domain and your range of the inverse functions. What's nice with this is domain of sine inverse. This is your range of sine inverse. This is your range of cosine inverse. This is your domain of cosine inverse. This is your range of tangent inverse, and this is your domain of tangent inverse. So we do have these here for you to reference and keep looking back at. Maybe put them on a post-it note. I also have off to the side our original sine, cosine, and tangent, and I have it written a little bit nicer for the inverse functions. Feel free to write them down, pause this, put it on a post-it note so that way you guys can attach it to the back of your unit circle or the trig chart you're going to be getting from me later in this chapter for all the different trig identities. All right, let's go ahead and get started. So example 3. No calculator, you guys. It'd be very easy to plug these in your calculator and get a decimal answer, but now the calculator's doing all the work for you. You need to do the work. Show me that you understand how to work with these composite trig functions. So before I start, we need to make sure that we look at what you're given. So here I am given sine inverse sine. So I'm going to look back here and I see here's sine inverse sine, and sine inverse sine equals x. They cancel and I'm left with x. But we need to make sure that our x falls between negative pi over 2 and pi over 2. It must be in quadrants 1 and 4. All right, so let's go back and look at A. So pi over 8, that's your x value. This is your x. So I want to make sure that that value fits between negative pi over 2 and pi over 2. If you do not recognize that pi over 8 is between negative 1/2 and 1/2, then get a common denominator. I can do that by multiplying by 4 over 4 and 4 over 4. I'm only going to show you how to get a common denominator once throughout all of these. So this becomes negative 4 pi over 8 less than or equal to pi over 8. That was already an 8, so I don't have to change that one. And then 4 pi over 8. There is an invisible 1 in front of that pi. Is 1 greater than negative 4 and less than 4? Yes, it is. Therefore, your answer is pi over 8. It does fit. That's your answer. It must fit. So now let's do an example where it doesn't fit. So I have 5 pi over 8. That's my x. It's still sine inverse sine. So x must be between negative pi over 2 and pi over 2. Get a common denominator again. I can turn 2 into 8 by multiplying by 4. So I get negative 4 pi over 8 is less than 5 pi over 8, less than 4 pi over 8. Is 5 greater than negative 4? Yes. Is 5 less than 4? No. 5 is bigger than 4. It is bigger by 1. If you're not sure, 5 pi over 8 minus 4 pi over 8 equals pi over 8. So I have found a value that is too big. And it's too big by that much. It is over just a little bit. Let me give you a visual. Ignore that for now. What this means. Here's my circle. Here is pi over 2. 5 pi over 8, this is equivalent to 4 pi over 8. 5 pi over 8 might be somewhere over here. So I am bigger, or it is bigger, by that much. That's pi over 8, the difference between these two. So what we have to do is we need to find where it matches on this side. So we have to take and subtract pi over 8. So 4 pi over 8, so let me come back over here. So I'm going to take 4 pi over 8 and I'm going to subtract pi over 8 and I get 3 pi over 8. That's your answer. If it doesn't fit, you figure out how much it's over and then you find its symmetry on the other side. So it's like double subtraction. You subtract the pi over 2. This is your pi over 2. This is your pi over 2. So nice little shortcut here. Put this on a post-it note, you guys. Add it in. So first you want to check. Does your x value fall between negative pi over 2 and pi over 2? If not, and again, get a common denominator. If not, you need to check how much you're over. So you're going to take your x, this is the x value, and you're going to subtract from pi over 2. Again, use your common denominator. And it's going to give you how much you're over. So in this case, we were over by pi over 8. Then you're going to take pi over 2, again, use the common denominator, and you're going to subtract how much you are over. And then that will be your answer. It is a process you need to follow. If you need to watch it again, watch it again. You need to do your practice problems though. Please do your practice problems. And if you get stuck, you need to ask for help. Please, I'm begging you. All right. Sine inverse sine. This is different than A and B. Sine inverse sine. Here we go. Sine inverse sine is, oh, that's nice. X must be between negative 1 and 1. If you remember what the graph looked like for the sine inverse, your graph was stuck between negative 1 and 1. It doesn't keep going on forever. So it must fit. If it doesn't fit, then it's undefined. It does not exist. So here's your x. 1/2 must be between negative 1 and 1. And yes, it is. Therefore, your answer is 1/2. 1.8 must be between negative 1 and 1. 1.8 is not between -1 and 1. If it was just 1, yes. If it was just 0.8, yes. But because it's 1.8, it's too big, it's over. The value I have is bigger than 1. Bigger than 1. So here, I have no solution. This is undefined. It does not exist. So whatever you want to put, does not exist, undefined, no solution. Something that tells me this doesn't work. 1.8 is not between -1 and 1. All right, let's move on to cosine now. We're going to do a few with cosine. So cosine inverse. Let's see here. Cosine inverse cosine. Let's go back and look. Cosine inverse cosine. X must be between 0 and pi. So let's see here. Here's our x. 0 less than or equal to pi over 12 less than or equal to pi. Get a common denominator if you want to. So you're going to multiply by 12 over 12. So 0 is less than or equal to pi over 12 less than or equal to 12 pi over 12. This is a 1 in front. Is 1 greater than 0? Yes. Is 1 less than 12? Yes. Therefore, your answer is pi over 12. So that one worked out nicely. Now let's move on to the next one. So we have -2 pi over 3. Well, what we need to remember is cosine is an even function. So your negative, this is the same as saying cosine inverse cosine of +2 pi over 3. So that's my x. 0 is less than or equal to 2 pi over 3 is less than or equal to pi. If you're good with fractions, you don't need to get a common denominator. Yes, 2/3 is less than pi. That works. So your answer is 2 pi over 3. Now I'm going to give you one example here. It's off to the side where you might want to put this on a post-it note and then just attach it to your notes, where we actually have to do some work. So here's your x value. So 7 pi over 6 must be between 0 and pi. You can get a common denominator if you prefer to have a common denominator. So I would multiply by 6 over 6. So 0 is less than or equal to 7 pi over 6 is less than or equal to 6 pi over 6. 7 is bigger than 0, but it is not less than 6. So I need to figure out how much I'm over. So 7 pi over 6 minus 6 pi over 6. So once I do this, I'm over here, which equals 7 minus 6 is 1. So pi over 6. That's how much I'm over. So now I'm going to take what I'm over and subtract it from pi. This is different than sine, where sine was pi over 2. This is pi because cosine must be between 0 and pi. So use your common denominator. I am going to take 6 pi over 6. That's pi. The 6's would cancel out. And I'm going to subtract how much I'm over. And I get 5 pi over 6. That would be your answer. So nice little note. You're going to take your x value and you're going to subtract it from pi. Then you're going to take pi and you're going to subtract however much you are over. And then that will give you your answer. Again, you can use a common denominator. Use your common denominator. So 6 over 6 was 1, which was pi. It'll make it easier for you, I promise. All right, let's move on. When cosine is on the outside, you have to, your x value must be between -1 and 1. Here, if you forget to say, oh, cosine's even, so this becomes positive, it's going to work out okay. So let's say we don't remember that, though you should. -0.4 is less than, okay, -0.4 is greater than -1, and -0.4 is less than 1. So yes, so your answer is -0.4. Pi is your x. -1 is less than or equal to pi is less than or equal to 1. But what you have to remember is pi is 3.14. Is 3.14 greater than -1? Yes. Is it less than 1? No. So this one is undefined. It does not exist. Sorry, I combined the D and the E. All right, let's move on to the last one. We'll be done with this video. Tangent inverse tangent. Tangent inverse tangent is the same as sine except for not equal to. Not equal to because those are our asymptotes in the graph. So this is my x value. So -pi/2 less than -2 pi/3 is less than pi/2. You can work with the negative. You don't have to work with the negative. It actually makes it easier when we don't work with the negative. You can pretend you're moving that negative to the front. Sorry. Since tangent is an odd function. Get a common denominator. 2 and 3 can make 6. So here you have to multiply all three numbers. So if here I'd have to multiply by 3, here I'd multiply by 2, and here 3 to get to 6. So -3 pi/6 less than -4 pi/6 is less than 3 pi/6. So whether you have the negative there or not, it doesn't make a difference. -4 is not greater than -3. So we have some work to do here. Even if I take that negative away, 4 is greater than -3, but it's not less than 3. So we have to be careful. You can work with the positive number, you can work with the negative number. It doesn't matter. It makes no difference at all which one you end up working with. You can work with the positive, you can work with the negative. Either way, we have to find the difference. So I'm just going to leave it as a positive 4 pi/6. So this is going to be 4 pi/6 minus 3 pi/6, which gives me pi/6. This is how much I am over. So now I need to find where it is symmetric on the other side. So I'm going to take the pi/2, which is 3 pi/6, and I'm going to subtract pi/6, which gives me 2 pi/6, which simplifies to pi/3. Please take your time working with these. Go very, very slow. Don't rush. You don't want to make mistakes. This last one, when tangent is on the outside, your domain is -infinity to infinity. Well, everything works. So it doesn't matter what x is, your answer is going to be whatever x is because of it being -infinity to infinity. All right. That's it for the first video. This is long enough. So examples 1 through 3, please get your practice problems done and questions, be ready with them in class. And I will see you tomorrow.